Record.
Yes, sir.
Yeah. Aditi, Samhita, Amtu Rahman, come on. Okay, so what was the question? The displacement of zero, right? Where is it? Okay, then let's do next. Displacement and time graphs. Aditi, Samhita, Rahman,
Yes.
Anon, turn on the camera.
Sure, 1 second.
Yeah, sure. Now, what this graph will show here, if I say here displacement and time,
Velocity.
what this graph shows?
Velocity.
Okay, velocity fine, but what it says, if I'm drawing the straight line on this
Oh, okay,
displacement
sorry.
time, what it
That
says?
means it's linear motion, uniform motion. Sorry.
Uniform motion, linear motion.
So it's at rest.
Yes, exactly. Object is not moving, it is at rest. Check that. Displacement is constant. Let it be, time is changing.
Yes, sir. Got it.
All right. So displacement is not changing with respect to time. Okay. So let's start this one. First, today we are just going to do graph. So many graphs we will discuss. All different type of graph. It's very, very important for your JEE exams. Okay. So today, what's the heading? Let's give a heading as various graph. Displacement, position, versus time, versus velocity, and time. Everything. Today we are just going to discuss all these graphs. So first one, let's give a heading here. Displacement, time, graph. Now in this axis, see what is there in x-axis?
Time.
Time axis, that is time axis. In y-axis,
Displacement.
okay. So this is displacement axis, that is time axis. So on displacement axis, a position is at some point. So that will be, if I take a difference in velocity or distance or displacement, that means velocity will be, what will be the velocity here?
Sir, can you repeat?
What will be velocity here?
Displacement by time.
Okay. What will be the value here at this
Zero,
particular
sir.
graph? Yes, it will be 0. At this particular graph, it is 0. So we can say body is at rest. Everyone join? No, still one more person is remaining. Samarth. Samita join, yes. Sadap, Kirtana, Garima, Aman, Aditi. Samarth yet to join. Okay. Let's check. Okay. Next. In displacement time graph, we will draw next one. This was the first one. Second one. Now what this shows?
Uniform motion.
It shows uniform motion. That means what with the velocity here?
Sure, a constant.
Yes. So it is at angle theta. So velocity is constant. So what we can write here? So here v equals to 0. That's what we got here. V equals to 0.
The body is moving with the same
Yeah.
velocity.
Exactly. At constant. Body is constant motion in displacement time graph. So in that case, it will be a linear graph. Like it is similar as linear graph. Then what will be difference between if I draw a line here and one more line if I draw here? What
So
these
it just
three lines?
shows how quickly it is traveling.
How linear it is. Yeah.
Yeah.
So for that, what we need, you said quickly trials, yes. So for that, what we need here? We need
The
velocity.
slope. Yeah.
Yeah, so velocity, to find velocity, yes, we need slope. So how do we find slope? Greater the slope, higher the velocity. So if I draw a line here, let me erase those extra lines. If I draw slope here, it will be dx by dt, which is equals to displacement we are taking at x time as t, tan theta. What is tan theta?
There is just a form of slope.
When I was kid, I used to remember like this Pandit Bole Prasad Har Bole. Yeah, but now it's different now. Previously, we were used to say perpendicular. Now different, like base, perpendicular, hypotenuse, hypotenuse, base.
So it's opposite by adjacent.
Exactly. Yeah, it changed. Okay. So V equals to tan theta. Now velocity, to find velocity, we will differentiate. To find velocity, differentiate what? Dx by dt, displacement by time. To find acceleration, we differentiate velocity with respect to time. So dv by dt. Okay.
Yes.
Then next, if see we saw one like straight line which velocity is 0 and one linear graph. Okay. Then third point, if it is uncommon, like this, all right, not this reverse. Something like this.
A non-uniform motion.
Yeah, it is not constant, not uniform motion. So we don't know like what, like, okay, for finding this one, we cannot do directly here. We have to integrate this, but it's not required right now. Okay. So if we want, if we have uneven graph or anything area, if you want to find area of that thing, that slope, or if area of what, if you want to find area of that shape, then we have to integrate with taking one strip and all that. That we studied in integration a little bit, right? Same manner. Like we'll substitute the limit. Okay, it's vary from some values to some other values, and we will remove strips from this point to that point, first point to another point. So that we'll see that. We'll do that later. Let's take this distance, sorry, displacement, this x, and this is time. So here, velocity is not constant. So that it will show a zigzag curve, sometimes increasing, some decreasing, some other point values. Everywhere it values are different. Okay, so what will the fourth one then?
Sir, good evening.
Good evening.
Manoj here, sir.
Yeah, okay. Hello, sir.
Good evening, students.
Good evening.
Good evening, sir.
So hope you all are enjoying. In between coming and disturbing you all. Children, your videos, I'm finding video is off. So that means you are not good. Am I correct? Your video should be on. If you are happy, really, your camera should be on. Interact with the teachers, so that teacher will also feel happy, no, interacting with you all. Still camera is off for Samhita, Kirtana, Ayush. Okay, so please ask your simple doubt also to sir. I think he is teaching in a very simple and easy way. Hope you all are enjoying the class. In case anytime if you feel difficulties, go through the recordings or you want any doubt clarification, feel free to post your doubt in the support group so that we will be responding you as soon as possible. Okay, beta?
Yes, sir.
Okay. Thank you all. Sir, please carry on.
Okay, sir. Okay. Okay, so velocity is not constant here. Let's go for next shape. Now, have you tried this? Have you heard of this parabola anytime?
Yes, sir. The graph of a quadratic equation.
Yeah. Okay. So this is your parabola. So in parabola, if I show you here, if I take each point of this axis, it will have 2 points on this one and this one. See, both sides we are getting. If I take one line from here, it can touch 2 lines of the x-axis. 2 values of x-axis possible. Okay, now here, there is not our right now concern. We'll have something more in this one. Okay. Now in this one, the same way if I can draw this reverse one. This is same as displacement and time graph. Same. Displacement, time graph. Okay. Now, especially this graph is for velocities, just for velocity, it's for acceleration. For accelerated motion, the slope of time displacement graph. So it will increase simultaneously. See the graph both sides. With one displacement value, we are getting 2 times. Okay. So imagine like in this case, if suppose, let me just change this position. If it is here, if it is at this point, it will have one positive value and one negative values also. Right? See this graph?
Yes, yes.
This parabola, we have 2 values of x. At suppose if we take a 1 for one value, this is 1 for y-axis. In that, for x-axis, we'll show 2 values. One is in positive side and one is in negative side. Okay, that is your parabola. So for accelerated motion, the slope of time displacement curve increases with time. So this is accelerated motion. And if I want to show deaccelerated motion, then it will be right side diagram. Are you able to understand?
Yes.
A is more than 0, A is less than 0. That means deaccelerated, negative values of A, this will be positive value of A. Accelerated motion. And this looks like smiley.
So for displacement time graphs, it gives both velocity and acceleration.
Yeah. No, not that way. Area under that will give you acceleration. I'll come to that point. This is accelerated motion. In short, velocity is changing every point. Accelerated means velocity is changing. Okay. So every moment velocity is changing. That is called accelerated motion. So let it be positive acceleration as we have first graph, which is smiley, and negative acceleration, that is a sad face, which is on next one. Okay. So it increases with time. And deaccelerated motion or decelerated motion Yeah, retardation. Slope of curve decrease with time. Okay. In this case, it is angle is not 90 degrees. It's not like perpendicular, right?
Yes.
So here, so it is theta is more
greater
than
than
90
90.
degree. Yeah. Greater than 90. So
Then it's a decreasing graph.
yeah, we can say that. Now that also depends upon point of reference.
Yes.
Displacement, time. So this, we can say this particle is moving towards the point of reference. So our time axis is point of reference. So it is moving towards the point of reference, so that it's making more than 90 degree. It's not exactly, it's more than 90 degree. We can see this. Exactly 90 degree means it will be right angle. It's not right angle. So clear all these 5 graphs.
Yes.
So particle or something is moving towards reference point. So reference point is your time axis. For in this case. Okay, then let's go with B. Velocity, time. This will give you acceleration. Now same thing we will do. Whatever we did on all this, same thing we are going to do. I'll draw a graph and I'll ask everyone one by one. You have to tell me what will happen in that case. Alright, not this graph, wait. Yes, Rahman, what will happen in this case? In velocity time? Velocity is constant. So what about acceleration? Zero. Because change in velocity is zero, that means velocity is acceleration is zero. Why change in velocity is zero? Because velocity is constant with respect to time. So this was the first one. Second one. Shadab, what about this one?
Yes, sir. Sir, this is a constant constant acceleration. So it's accelerating with the same rate.
So acceleration will be, how to find this acceleration?
So it
Slow,
would be v by t. So yeah, slow.
dv by dx,
Yes.
dt. Sorry,
dt.
dv by dt. That is a. That means tan theta. So first one, velocity of particle is constant. So acceleration is 0. Second one is moving at constant speed. So initial velocity is 0. Finally something. It is, so we can say, in short, we can say it is accelerated motion. Can we say that?
Yes, sir. It's accelerating.
Accelerated motion. So it is increasing acceleration.
No, sir.
No. See, understand one thing, when we are writing acceleration unit, what is the unit of acceleration? Do you remember?
Meters per second square.
Meter per second square. What does this meaning? What this meter per second means? Not meaning. What does this meter per second means? How we got this? By meter per second by second, right? This is your velocity or speed, whatever. This is your another time. So every second there is an addition of 1 meter per second in your velocity. That's what it means. So that means when we are saying 1 meter per second square is acceleration, that means we are increasing speed or velocity, whatever it is, with 1 meter per second every second.
Yes, sir.
Okay, understand this meaning also. It's very, very important. Because in this question, not in this question, this like kinematics, only you have to just move around acceleration, velocity, time, acceleration, velocity, time. Just 3 things. This is your world now. For whole kinematics, acceleration, velocity, time. And if we go with dynamics, it will be, we have to add one more thing, that is mass. Acceleration, velocity, time, and mass. That will be giving you 3 chapters. So this will eat your head if you don't understand meaning of each definition, each word. Okay, third one, I want the Samhita to give explanation.
So wrap it out.
Yeah.
So that means velocity time graphs give slope gives acceleration, right?
Yes.
And then for displacement, it's
Velocity. Yeah.
But then I had it out because you took acceleration last time, right?
Which one, dear? Which one?
For the fourth one.
Okay. Am I audible? I got disconnected.
Yes.
Okay.
So now you're audible.
Okay. Yes, Samhita, you are asking some doubt in this one?
Oh yes, sir. I was asking how it was accelerating because you told that displacement time graphs shows velocity.
Velocity. Yeah. It is accelerated motion means increasing speed. Accelerated motion. I'm not saying acceleration. I'm saying accelerated motion means changing velocity is acceleration in short. Changing velocity is acceleration or deceleration. If it is increasing, means acceleration. If it is decreasing, deceleration. So
Yes.
whenever we say accelerated motion, means we are changing velocity. That's what it means. So here, displacement time will give you acceleration, sorry, velocity. So that velocity is changing. So this is acceleration, accelerated motion. It is increasing side with time. Now here with time, it is decreasing. We are getting less values of distance. Here we are getting more values of distance. So it is decreasing and this is increasing.
Yes.
Okay.
Sir.
Yeah. What happened to others? Everyone went blank. I can see only black screen. Yes, Shamhita. What about this one?
So showing retardation.
It will show retardation. It is constantly decreasing. Fourth one, I used to give answer.
Yes.
What about this one?
So accelerated but not constant acceleration.
Yeah, it's not constant. But it is accelerating, but not constant, right?
Yes, sir.
So initial velocity is,
It's zero.
Zero.
yeah, it's starting from zero actually. I couldn't draw here properly. You can start from zero itself. Zero. So this is non-uniform acceleration, we can say. Now, who left? Aditi, your turn. Aditi, are you there?
Yes, sir.
Okay. What will be this one?
Uh, acceleration will
I'm just simply drawing whatever is coming in mind and asking you what will be the graph.
was I correct, sir?
What you said again?
Acceleration will increase and decrease with time.
So it is both, right? Where is increasing, where is decreasing?
First it decreases and then it increases.
Yeah. So actually these are all standard graphs. This some exam they ask in this one, and so I just saw it and I just asking you. Decreasing acceleration, increasing acceleration, both.
So how is it possible at the same time?
No, this graph shows decreasing, this graph shows increasing.
So they're two different.
Yeah, they are two different. That is obviously not possible to show both things. What happened? Why you turn off your camera? Why did you turn off your camera? It's okay, you can eat. I said, no, I say same thing I said yesterday. You can eat whatever you want. It's okay. I don't mind that. ठीक है. Oh, any graph left? Okay, we'll draw a graph and do some numerical. Okay, what this graph shows? Anyone can give answer? Okay, let me ask Kirtana.
Sure.
Oh, yeah, want to say something? Shada? Yeah.
No, sir, I was just trying to answer, but you can go ahead.
Okay, you can answer. It's okay. Say
I was saying maybe area under the graph.
area under graph. So what it will show? Will it
So area under the graph
would show what? Acceleration? Acceleration is a slope. I think so. Your mic
there
is
is displacement, right?
yeah. Okay. Yes, Samhita, what do you think? What this graph shows? Acceleration, displacement.
Displacement, sir.
Okay. Aditi, what about you? What do you think?
Yes, sir, it's displacement.
Not acceleration. See, V and T graph will show you what? Acceleration, but why it's showing displacement?
Sir, for area under the graph, basically you have to multiply both the axes. Velocity would be displacement by time multiplied by time. Time gets cancelled and you get displacement.
ठीक है. Correct. Yeah. So it gives displacement. So area enclosed by velocity time curve, it represent distance travel by excuse me, by
So, sir, differentiating a velocity time graph would give you acceleration, and integrating it would give you the displacement.
exactly. I was about to say same thing. Are you reading my mind?
Yes.
Very bad. ठीक है. So yes, he said correct. This differentiating will give you like acceleration. If we integrate, we'll get distance. Now, see here in this case, actually distance displacement we are considering same, but if we want auxiliary displacement, then what we'll do? We have to just consider sign. If we don't consider sign, it will be distance. If we consider signs, it will be displacement. That's it. The small difference. And what would be the, what do I mean by sign?
Positive or negative?
Yeah. So if we consider those things, it will be like displacement. Like if he went that side, he went up, down, and whatever way he went in the graph. So to see all the directions and all that. When we are considering direction, that time it is displacement. So let's draw one graph and solve one question. So there are how many points? 2, 4, 6, 8 means 5. 4, 8, 10. -10, 20, -10, -20. ठीक है. Okay, as shown in figure, no? That means I have to draw this. It starts from 0. I think so. My distance are not equal. You make it equal. It should pass through 6 and touch this point at 20. Oh, they're almost equal. Nice. So this is touching at 20 and this is touching at 10. So what are these points? A, B, yeah, C, and D. Time T in seconds, U in meter per second. Okay, this is velocity time graph. moving straight line as shown with find displacement and distance traveled in 10 seconds. Traveled in 10 seconds. चलो सॉल्व करो. For distance travel, what we'll do? We have to follow the exact path, right? Let it be in negative side or let it be in positive side. ठीक है. Once you finish question, tell me. I'll start timer. I want to answer in 15 seconds. No, sorry, not 15 seconds. 30 seconds. Even seeing graph also, you can answer this. No, you can have to find area. It will be 10 into 4. 10 into 2. 10 to नहीं बच्चे, how come 10? See here only I'm getting 10. That is time what you calculated. I want distance. So what I'll do, without considering sign, we have to find just add all the areas. Yeah, even I forgot that one. That is 20. 20 means 10 into 2, 10 into 2, 10 into 2.
So I sent you my answer.
3. No, displacement cannot be 0.
Yeah, 1 second.
Distance. Again, distance.
Wait a minute, I missed something.
Exactly. I hope so. You are correct. After that, distance is also wrong.
Sir, how about now?
Wrong. Samhita, Ayush, Rahman, Aditi, Kirtana. What about you guys?
Sir, I sent my answer.
Distance is nahi rahe.
Sir, mine is wrong.
Aditi, yes, your answer is also wrong. Till now, I didn't got any correct answer. It is very simple. I just did orally. What you're guessing or what? You're increasing 10, 10, 10.
No, sir.
First, your answer was 8. Then you increased one more 0. Cheap. And no, not yet correct. Rahman, not correct. Arey yaar, not 160 then 260. Hey, what is this? Shadab, what happened?
One sec.
Arey, see, I'll give you one hint now. I got so many wrong answers. Not so many, every wrong answer. Okay, I'm waiting for Kirtana. Kirtana? Are you connected? Nahi? Ayush, what about you? Guys, am I audible, right? Am I audible, guys? I'm getting disconnected now.
Yes, sir. Now I can hear you.
Okay. With somewhat I cannot understand. He's frozen or like is there? Okay. Okay then. Let me give you a small hint about this. See, first one.
Who's-
Okay, you want me to wait? I'll give you one small hint. See, find out this area 2, area 3, area 4. Add all for distance. Now subtract the third area with all these 3 for displacement. That's it.
Sir,
Yes?
I think I disconnected. Is my answer wrong?
You send answer?
Yeah.
What is that answer? Let me check.
I sent it again.
Ah, that is correct.
Okay, fine.
But I'm talking about distance.
Yeah, one sec.
Did you send this value before? No. Samhita sent that answer, but that is different. She gave. No. Yeah. Aditi, what is
Sir,
this?
how about for distance?
No, correct.
Okay.
Finally, you got correct.
Yeah.
After how many attempts? How many try?
I think 3 or 4.
Go ahead. So you should not give up until you get correct answer. Aditi, you're going somewhere only. What you're doing? Yeah, sometimes you're getting so high value, sometimes you're getting very low value. Aditi, are you there?
Yeah, sir.
Okay. Okay, then let me solve it. So for distance, see, area for this one, VT graph, I need, somebody wrote answer, wait. Correct, Aditi, very good. So finally, you also got answer. Super. Now, distance we have here like 2 and 2 and 4. Okay, and another one is 6. So how many 20s are there? 1, 2, and 3. So total, if I take all this, they are same actually, right? So distance means 1 by 2 half into base into height. So 6 into 20 plus another half, 2 into 20 plus another half, 2 into 10. So it will give me 10, 10, 5, 5 is a 10, and 2, 200, sorry, 20, and 60, 60 plus 20, 20, 70 plus 20, 90, 90 meters. Now, displacement, half, as usual, 6 into 20 minus into 2 into 20 into, not into, plus 10. So 10, 10, 10. So this will get cancelled. So it will be 50.
Sir, could you scroll to diagram once?
Yeah. तो बोलो बच्चा लोग समझ में आया?
Yes.
Yes. Yes, sir.
Easy?
Yes.
Everyone?
Yes.
Rahman, Ayush, Garima,
Yes,
Kirtana,
sir.
Shadab,
Yes,
सबने
sir.
कहा। ठीक है। What about Aditi? Done right?
Yes, sir.
You got answer, right? Okay. Okay, done everyone? Shall I stop sharing?
Yes, sir.
So tomorrow not tomorrow. Tomorrow we have class, right? Yeah. Right. Okay, Sunday we'll have test on this one. Little small test. Few questions. ठीक है?
Okay, sir.
Yes, sir. No problem.
Yes, sir.